Hello and welcome. This is lesson 4.6 on our trigonometry series, the first trigonometry unit we're going over. We're going to take a look at the graphs of cosine, sine, and tangent in this. So we're going to look at these functions as kind of more abstract functions. The last week we were practicing right triangle trigonometry, and now we're going to go back to the unit circle definitions for these and let the angle extend on and on and on, both for positive values, any positive angle you want, and for negative values as well. Okay, so without further ado, let's go talk about the learning objectives. So first, our learning objective is to graph the three functions, cosine, sine, and tangent. And then we want to use their graphs to solve some problems. And let's try to determine the domain and range for each of these functions as well while we're at it. When you graph a function, it becomes a lot easier to visualize the domain because you just scan it from left to right. And you can visualize the range because you scan it from bottom to top. And if you have graph, then it's in the domain or it's in the range. So if your lines hit the graph, then you... Okay, so let's first build a table of values for the three functions of interest, cosine, sine, and tangent. So I gave angles in both radians and degrees, and then the values for cosine, for sine, and for tangent. So for example, if my angle is 0, so if I recall the unit circle and I draw an angle of 0, that's my point for an angle of 0. And the cosine, which is the x, this is 1, 0, 1, 0. The cosine, which is the x, is 1. And the sine, which is the y, is 0. The tangent is the slope of that radius, slope of this radius, and that's 0. It's sine divided by cosine. If we go to an angle of pi over 6, or 30 degrees, either way that you want to think about it, we're going to do our graphs all in radians, so I'm just giving you the degrees right now for a refresher. Then the cosine square root 3 over 2, and the sine is 1/2. Now, when we're plotting, it's good to know where square root 3 over 2 is as a decimal. It's about 0.866. So when we plot this, we're going to make our y-coordinate roughly 0.866 for cosine. So when we plot cosine's graph, it's the height there is going to be about 0.866. Tangent of 30 or pi over 6 is root 3 over 3. So these should all be familiar values to you. I've just laid them out in a table, a nice format, and you can have this table if you would like. You can copy it down in. Note that at 90 degrees or at pi over 2 radians, the tangent's undefined. That's when it's vertical. We have an undefined tangent there. And as an exercise, a thought exercise, what would happen to this table's values if you extend it for negative angles? So first, if you extend it in this direction as well, so the next nice angle from the unit circle after 90 is 120 degrees. And that equates to 2 pi over 3. So you could fill out cosine, sine, and tangent for that, and so forth. And if you were to work backwards, so if you were to go into negative angles, what would those look like? Well, the next nice negative angle is negative 30 degrees, or negative pi over 6. And if you were to sketch that, you should see what happens. You have the same cosine as cosine of 30, which is square root 3 over 2. And the sine is the same value but negative, absolute value but negative. And then the tangent would be negative root 3 over 3. Okay, so I'll let you go back and try to extend this table for negative values and continuing past the first quadrant. This is only the first quadrant, and how would this look like if you can go try to extend this table as an exercise for yourself? Okay, so let's go ahead and try to build the graph of cosine from that table. And I'm going to have my handy dandy unit circle here to remind me about values for cosine. I have worked out the values for cosine all the way up to an angle of pi. So that's these first 1, 2, 3, 4, 5, 6, 7, 8, 9 values of cosine. And you can see we can continue going down the unit circle if we want to. So starting over at 0 radians, our cosine is 1. At pi over 6 radians, the cosine is square root 3 over 2. At pi over 4, it's root 2 over 2. That's nice. Pi over 3, it's a half. That's where it's a half. Pi over 2 is equal to 0. 2 pi over 3, that's equal to negative 1/2. 3 pi over 4, that's equal to negative square root 2 over 2. 5 pi over 6, that's where it's equal to negative root 3 over 2. And then at pi, our cosine is negative 1. Okay? As we continue on around the unit circle, we can get more and more values for cosine. All the way till we're back to 2 pi, and then it repeats. The cycle repeats. It repeats, it repeats, it repeats. So let's go ahead and try to graph these angle cosine pairs on the coordinate plane here. So our axis here, our x-axis is the angle, theta, in radians, and the y-axis is going to be the cosine of the angle. So this is kind of like, so that's our answers are going to go on the y-axis, just like you would for a normal function. Okay, so let's plot some points here. We have 0, 1. So I'm going to plot 0, 1. That's up here. We have pi over 6, and then root 3 over 2, which is about 0.866. So I'm going to plot 0.866. That's 0.9 is halfway between 0.8 and 1, so 0.866 is roughly about there. So we have 0, 1 up there, we have 0.866 there. Pi over 4 is 0.7, half right here, so it's about 0.7, right around there. It's about 0.7. At pi over 3, we're at 1/2 exactly, so that's about right here. And then at pi over 2, we're at 0, so that's down here. Okay, so I'm going to go ahead and connect this with a nice smooth, so boom, there's the first bit of the cosine graph. Once we get to 2 pi over 3, our value gets negative, so that's negative down here. Negative 0.5. 3 pi over 4, it's negative 0.7 here, about that. And then at 5 pi over 6, it's negative 0.866. And then at pi, we've made it to negative 1. So let's go ahead and, alright, so that's the first little bit of cosine. If we continue our way around the unit circle, we can see 7 pi over 6 is the same as 5 pi over 6, which is negative root 3 over 2. So these two have the same cosine. The angle of 5 pi over 6 and the angle of 7 pi over 6 give you the same value of cosine. They're both negative square root 3 over 2. And so that means at 7 pi over 6, we're at the same height over there as we were at 5 pi over 6. So these are the same y coordinates. And then 5 pi over 4, it's negative root 2 over 2. So that's negative 0.7. And then at 4 pi over 3 is negative 1/2. 4 pi over 3, negative 1/2. 3 pi over 2, it's at 0. So we're back to 0 with curve connecting these. As we make our way back around into quadrant 4, we've got these triangles to look at, right? 1/2 root 2 over 2, square root 3 over 2. And then lastly, back to 2 pi where it's equal to 1. So I know it's 1 up here at 2 pi. I know at 5 pi over 3, it's 1/2. And at 7 pi over 4, it is 0.7, roughly. And then at 11 pi over 6, it's about 0.866. We'll connect, shabam. The function repeats. That is the graph of cosine. From this, we can determine the domain and range. The domain is just all real numbers. You can plug any angle in. There's any angle you can plug in for cosine. You can put in a positive angle, you can put in a negative angle, you can put in 0. There's no restriction on the angle. So our domain is all real numbers. The range, we should be able to determine the range of values. What could we get out from the cosine function? Well, the cosine function is stuck forever between these two numbers, negative 1 at the bottom and 1 at the top. It's sometimes -1, it's sometimes 1, and it's all the numbers in between, but it's never more than -1. It's never less than -1, and it's never greater than 1. So our range is everything from -1 to 1 inclusive for the graph of cosine. For sine, we're going to find that it fits the same domain and range as cosine. Okay, so there's the cosine graph, starting at 0, 1, and then once we go through this little kind of wave curve, and when we make it to 2 pi, we're back to where we started, and we just repeat this graph every 2 pi. So we get another copy of this graph if we were to graph from 2 pi to 4 pi and so on. We just get the same values. Okay, let's go ahead and graph sine. So graphing sine of theta, we again have a table to work with. I pulled this table from the unit circle. Sine starts off at 0, meaning if you plug in an angle of 0, you get a y-coordinate of 0 out. So we're going to plot 0, 0. I'm going to go through this one faster than the last one, and if you need to slow down, need to see to kind of like plot it yourself first or slow it down, you can feel free to. So pi over 6 is a half, so that's up here. The next one's about 0.766, so that's about here. And then at pi over 2 it's equal to 1, so that's up here. So we have this curve, and then I know at pi we're back to 0. And then we have these same sets of values on the other side as we make our way back down from the top. So we were going up the unit circle, and now we're coming back down and hitting the same y values on the way back. So 2 pi over 3 is 0.866, a pi is 0.7-ish, 5 pi over 6 is 0.5, pi is back. Looks a lot like the cosine graph, but shifted, which is what it is. We know at 3 pi over 2 it's going to be at -1, and 2 pi it's going to be at 0 again. So at 3 pi over 2 its y-coordinate is -1, at 2 pi it's back to where we started, 0. And then 7 pi over 6 it's -0.5, 0.7-ish. And then -0.866 roughly. Again, -0.86, -0.75. Put a little pretty cloud here, maybe a tree on the graph. Graphing with Bob Ross. That would be a great show. I would watch that show. Graphing with Bob Ross. We'll just put a little graph of cosine here and dabble a little cloud, and oh no, we've got some rain coming down onto our... Anyway, that's not part of the graph of sine or cosine. But anyway, that's water filling up. Anyway, that would be the graph of sine. It looks a lot like the graph of cosine, but it's shifted, and that's in fact. Okay, building the graph of tangent. Tangent is a bit odder from sine and cosine. Just real quick before I depart this one. Whoops, go back. Okay, before I depart, domain, all real numbers. Any angle, range, -1 to 1, identical to cosine's domain and range. Okay, so again, it's easy to see that from the graph. Any angle you can plug in, range is domain is all real numbers. You're only getting values between -1 and 1, so that's the range. Okay, tangent. Last but not least, let's graph tangent. Tangent has vertical asymptotes because we'll find that when you try to divide by 0, if you think about this as slope, right? So our slope right here is incredibly steep, and the closer we get to pi over 2, the steeper the slope is to infinity. So it's going to be as steep of a line as you want it to be. So the tangent will approach infinity as we get close to pi over 2. And when we're at pi over 2, it's undefined. So we'll find that ends up being a vertical asymptote behavior. Close to pi over 2, the tangent is very large and positive. Once you move to the other side of pi over 2, all of a sudden, we have a very steep and negative slope. So we're going to be a very large negative number just on the other side of pi over 2. Everything else in between, we should be able to graph just fine. So we have 0, 0 on our graph, pi over 6, 0.577, so we'll go ahead and graph that one. That's about here. Pi over 4 is equal to 1, and pi over 4. Tan of pi over 3 is about 1.7, this-ish. Pi over 2 is our vertical asymptote. Remember I said as we get close to pi over 2, it's getting bigger and bigger and bigger. So it looks like we're going to curve up to infinity like that. Though I don't show you on our table, it does in fact curve down to the left over there. And then we're going to have another vertical asymptote when we're at 3 pi over 2. That's the other time the slope is undefined. So at 3 pi over 2, we have another vertical asymptote. Okay, so moving into the second quadrant, at 2/3 of pi, we're negative square root 3. So that's down here, negative 1.7-ish. And at 3/4 of pi, we're at negative 1. It's about there. 5 pi over 6, we're about negative 0.577. And then we're at 0 here. So we're coming in from negative infinity towards 0. This graph is going to repeat. We're going to have the same values for tangent at 7 pi over 6, 5 pi over 4, and 4 pi over 3, as we did at pi over 6, pi over 4, and pi over 3. So 7 pi over 6 and pi over 6 have the same tangent. 5 pi over 4 and pi over 4 have the same tangent. 4 pi over 3 and pi over 3 have the same tangent. So we're going to get a copy of that pit right here. Okay? And this is going to be 0 again there. So we get this nice repeating curve behavior for a tangent. And one thing to see from this picture is it repeats a bit faster than sine and cosine do. We'll talk about this repeating behavior more formally in a later video. It's called the period of the function. It repeats every pi, in this case for tangent. Cosine and sine repeat every 2 pi. So they have different cycles, if you will, before they come back to where they were before. The domain and range from this, we can identify the domain. Domain is a bit funky to say. The domain for the tangent function, I'm going to just say it this way. It's any number that is not pi over 2 plus a multiple of pi. So it's any angle that's not pi over 2 plus a multiple of pi. So for example, pi over 2 is not allowed. Pi over 2 plus pi, which is 3/2 of pi, 3 pi over 2 is not allowed. 5 pi over 2 is not allowed, okay? So we can see that the pattern is you can't have the angle be a pi over 2 plus a multiple of pi. Anytime that happens, you're going to be on one of these, you're going to be on this y-axis where the slope is undefined. The range we can see from the graph is all real numbers, right? Where you're going to have any slope you want. You can have a very large positive slope, you can have a slope of 0, you can have a very large negative slope. So all the slopes get hit as we move, through the angles, okay? So from the graph you can see the range is all real numbers. And the domain has these not allowed values that repeat in a regular fashion. Pi over 2 plus a multiple of pi, can't plug those numbers in. Test it out. Try plugging in pi over 2 plus 3 pi into tangent. You'll get undefined, okay? All right. Anytime that the cosine would be 0. All right, I want to show you a slight little demo, and then I'll wrap this video up. This is my unwrapping the unit circle demo. I like this graphic. I like this visualization a lot, actually. Oops, down in the corner. Okay, so here we have the unit circle, and I have the graph of cosine in blue. So this is the graph of cosine. Remember, cosine starts at 0, 1. And my angle, I'm starting at negative 2 pi. So the angle of negative 2 pi, I've sketched the radius on the unit circle, is at negative 2 pi. It's the same as the angle of 0. Okay, now we're going to watch. This point is the cosine. The y value is the cosine for that angle. So the blue, you can kind of think, okay, so green, that dot on the unit circle, is the point on the unit circle for a specific angle. And then this other green dot is the point on the graph of cosine that matches to that angle. Okay? So let's go ahead and hit run. So as my angle is increasing, we're moving in the positive angle direction. The x-coordinate for this point on the unit circle is the y-coordinate for the point on the graph of cosine. Okay, so we're now at an angle, we're getting close to pi over 2. There's our pi over 2 angle. So I want you to be looking at this number here. We can just pause it real quick. Boom. Oops, pause. Okay, so this point, its x-coordinate, negative 7.48, is the y-coordinate for the point on the graph of cosine. This number right here is the angle in radians. So that would be about a 3.868 angle, okay? We'll keep going. So we can see, boom, the x is 0. The x is getting bigger, it's going towards 1, it's going towards 1, boom, it's 1. Okay, and then it repeats itself. So that is kind of how the graph of cosine is drawn from the graph, from the point on the unit circle. Now I'm going to look at sine. So instead of cosine, let's go ahead and look at sine's graph real quick. So here's sine of x. Notice it's a little bit different from cosine. It looks like cosine's graph, but it's been shifted to the right by an amount. So now we're starting at, again, negative 2 pi for my angle, and the y-coordinate is 0. So the y-coordinate here matches the y-coordinate here. You can see 0.003 and 0.003, so those match up. We'll go ahead and get it started. So my y is increasing towards 1. So they have the same y, so be watching this y-coordinate. It's decreasing, and then 0 at negative pi, and then negative 1, so we're negative 1, we're at the bottom of the unit circle. We're moving to the right part, 0 is the y value. Our y value is increasing, and then it's 1 at pi over 2. The y value is decreasing, it's 0 at pi. The y value is decreasing and negative, it's negative 1. And then it's starting to increase again towards 0 when we hit 2 pi again. Boom. So that's the graph of sine, and it's just the y-coordinate for that point. Lastly, let's look at tangent. So here's the graph of tangent. And again, starting it at negative 2 pi, where the slope is 0, we can see that as our slope increases, boom, we're going off to infinity, and it's undefined. And we have a very steep negative slope of 0, a slope that's positive and increasing, positive and increasing, positive and increasing, undefined, negative, negative increasing, 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 and then 0, and then positive and increasing slope, positive and increasing slope, and infinity, negative increasing, negative increasing, and then 0 slope, positive slope, getting bigger, getting steeper, getting steeper, getting steeper, boom, off to infinity, negative slope, getting bigger, getting bigger, getting bigger, getting to 0, and then, all right, and then it repeats itself. Okay, so that's the graph of tangent. It's the slope of the radius. So as the radius gets steeper, we're blowing up to infinity, and then once we go just to the other side of that asymptote, we are a very steep and negative slope. So I'll just pause it right. So right there, the slope of the line is very negative, very steep and negative. So you can see it's a negative slope. That's why we're below the x-axis here. Okay, so that's the graphs of cosine, sine, and tangent from the unit circle. I'll go through an example in another video. I feel like this video is already long enough. We've graphed cosine, we've graphed sine, we've graphed tangent, and we've looked at how these graphs compare with the unit circle, and how they come from the unit circle. Okay? And so the next little bit, I'll do some examples, but that will be in the next video where we determine x's or angles based off of sine and cosine, based off equations.